Just a brief introduction. My name is Sunny Gupta, and I'm having total around 14 plus years of experience in IT industry. So today's topic is basically Apache Kafka. So let me present it. So basically, it's a open source distributed event streaming platform, wherein whenever we talk about event driven architecture, so this is the major thing right now, which is mainly used in most of the companies which work on event driven architecture. Okay, so the topics that we are going to cover in this session are like, we will discuss about Kafka topic, what it is, and how like there are partitions in a topic, how the partitions are being managed, and we'll talk about the brokers also. And we have like producer and consumer libraries in Kafka, like, and also we'll talk about consumer groups, and yeah, here and there we need to like understand the event driven architecture also. So whenever like, this is the overall picture of Kafka, how it is used. So on the top most, you'll see transaction systems, the eventing systems, and data streams and alerts, which are ingesting data into Kafka. And we have some databases or auditing system or analytics is based on the consumption of the messages. After consuming the messages, we are doing some analytics, or some emailing part is being done after consuming the messages. And the topmost are the producers, and the downwards are the consumers basically. So I'm giving you an example of the like one of the systems. For example, in e-commerce industry, you have some order management service, right, wherein you have some orders API to create the orders. And you have some downstream services like payment service and email service. So after creating the order, you will call them to like for the payment deduction, or for sending the email to the user for the order confirmation. Okay. So for example, at that point of time, if your downstream services are not available, they are down. So you need to develop some retry mechanism, or need to take the status of the payment, whether it's taken or not, or need to write the background jobs to for the retry logic and all, right? But similar use case, if you see, if you like store the events in Kafka cluster, for example, you have some topics, you can say topic, you can assume like a table in a database. Okay, whenever you are storing something in a database, you are storing it in a table. So similar way, if you are storing something in Kafka, you are storing it in a topic. The topic is a logical unit, but if you talk about the physical thing, it's a partition basically. So we'll talk about that in the next few slides. So for now, you can take it as a like logical unit where you are storing something. So you are publishing some event on your Kafka cluster as soon as your order gets booked, or your create order API gets called. Okay, and you have different services. I mean, even if they are down that time, but as soon as they are up, their consumers can listen those events from Kafka cluster and do some processing. I mean, like payment service can do its job, and email service can send the data or the emails to the concerned user based upon the order confirmation. Okay, so this is how Kafka fit in into this producer consumer system. So here producer is the orders API, which is producing events to Kafka cluster. And we have multiple consumers which are consuming the messages from the Kafka cluster, which are like these payment service and email service. Okay. Now we'll talk about like topic. As I already told you, like it's a logical unit wherein you are storing the events in Kafka cluster. Okay. Now it is further divided into partitions. So as I have already highlighted here, just a minute. As I've already highlighted here, this is partition 0, partition 1, and partition 2. Okay, so there are 3 partition in this topic, and there are consumer groups. We'll cover them in later slides, but just think topic as a logical unit where you're storing the events, and it is further divided into partitions. How partitions are being stored, that we will see. Now, this is the inside view of a like topic. For example, you have a single topic. You can name this topic as orders topic. For example, you have some orders of the users which are you are storing here in this topic. Okay, they are nothing but order events. For example, state of the order, what it is, like order created, order delivered, like that you are storing in this topic. And also some other metadata with the topic in the event. And this topic is further divided into multiple partitions. So this is partition 0, partition 1, and partition 2. So partition, you can understand it as a log file. For example, you are having like a log file wherein it's a append only log, right? You are just appending the data at the end of the file. So similar way, you can understand partition also as a log file wherein you are appending the messages or events at the end of the file. So for example, first message you are appending to the log is having offset 0, then offset 1, then offset 2, like that. So in partition 0, there are 6 messages starting from offset 0 to offset 5. Okay, and if there is anything written to it now, so it will be written as like offset 6 in partition 0. Similar way, you have partition 1. So generally you keep every partition into a different node, physical node. I mean, physical machine, you will keep them on separate nodes. You will try to keep them on separate nodes, every partition of yours. Okay, so you can treat them like they are different log files on different machines, and they belong to single topic. So whenever I want to store some data in this topic, so it can be stored either in partition 0 or in 1 or in 2. I mean, either of these it can be stored, but either one of these it will be stored. For example, I want to store some event. So let us see that what is the logic behind, I mean, how it is being decided that on which partition that event is being stored. I hope till now the things are clear. If you have any questions, you can ask. Okay, I'll assume that there are no questions. So I'll move ahead. So we'll talk about now producers, how producers are producing data on your Kafka cluster. Okay, so whenever producer wants to produce anything, so it needs to provide like the data it wants to produce, and also it can also provide a key with that message. Okay, based upon that key, it is being decided that the message that producer is sending, so it will reside on which partition. So Kafka has some like some hashing algorithm is there. Based upon that, that key will automatically go to the same partition every time whenever it is sending, whenever producer is sending some data with the same key. For example, it is sending some data with key ABC, so ABC will go to same partition. For example, here it is going to partition 0, and XYZ is always going to partition 1. So I'm giving you an example. For example, you are receiving orders or you are receiving some ride data in Uber. Okay, and you are getting like ride events basically. So for if you want like the same user's event should be in sequence, so you will shard or you will hash your, when your key will be user ID then. So now all the same user's data will be sent to the same partition. So whenever you are now reading the data by some consumer, so it will be in sequence. Okay, so this is the how, if you want to keep your data like process it in order, so you can decide your key accordingly from the producer itself. Okay, now we'll see the replication strategy basically. So whenever, so these three brokers are three different machines, okay, of Kafka cluster, and you have like on every machine you have some partition kept. So if you only keep one copy of partition, so if that, for example, you have only kept this one copy of partition 0 for topic A, then if this machine goes down, then you have availability problems, right? Because you are not now, you're not able to get the data on partition 0 because your broken one is down. That is why you need to specify the replication factor while doing the configuration, while creating the topics and all, so that it will keep a copy of this topic to some other broker machine as well. For example, now we have kept this replication factor of 2 in case of topic A. So it is keeping like topic A partition 0 is kept at broker 1 as well as it is kept at broker 2. But there is one more thing, that it will always allow writes on the leader uh, replica basically. So for example, this is the leader and this is the follower. So it will only allow writes to this partition, and follower will be the in sync replica. So it is syncing the data from this partition, and just like it will be in sync with the leader replica. Leader basically, not the replica. This one is the replica. So that's why it is maintaining the copy of data, multiple copies of data. So replication factor ensures that your partition will be kept at multiple nodes, just to ensure that you are available every time. Now we'll talk about consumer group basically. So now you have seen that producers are producing your data. One more thing I just forgot to tell you. For example, you need to uniquely identify a message. So you can uniquely identify it via topic name plus partition ID plus the offset. So this is the uniquely. If you want to reach to a particular message, so your topic name plus partition name plus offset will give you that particular message, because same offset can be on this partition as well. But if you have the partition name and the offset, then you will reach on to that particular message only. Okay. Now I'll see the consumer groups. So consumer groups is basically whenever you want to consume some data from Kafka. So it's a producer consumer kind of a system where producers are producing the data, and now we have consumers which are consuming those messages and doing some processing based upon the consumption. For example, if you get an order event, now you need to send the email to that user. So that is done by this consumer after listening to the event that is produced by the order API. Okay. So this is, I am telling you right now, the automatic, you, whenever you are just doing the automatic configuration from Kafka itself. Like, so whenever you create a consumer and you will add that into a consumer group. So every consumer is part of some consumer group only. Even if you don't specify, it will take a null consumer group, or it will take, a random consumer group based upon, broker will create at its end. Okay. So whenever you say add one consumer, so it will start, and consumer will specify that from which topic it wants to listen to the messages. So for example, this consumer is specifying that I want to listen from topic T1. So there are now 4 partitions on this topic. For example, if I would say that all the partitions are on different machines, and that's how it is taking the messages from each partition. So like, for example, here we have like partition 0 and partition 1 and partition 2. For example, I have created a consumer group, and for example, this topic name is order topic, and that consumer is listening from order topic. So it will start listening from partition 0, 1 and 2, and it will start getting these messages like 0 of partition 0, then 0 of partition 1, and 0 of partition 2. This is how it is starting taking messages based upon some batch size you can configure, like I want 10 messages or 20 messages per call. So based upon that, it starts consuming messages from each of the partitions. Few messages from each of the partition, because it's a single consumer. So Kafka's responsibility is to send messages from each of the partitions. Okay. Now we'll see when we add one more consumer to this consumer group. Now there is something called rebalancing in Kafka. So rebalancing means it again now reassigns the partitions to the new consumer. So like here, all the partitions are being consumed by consumer 1 only, right? Here you can see that whenever consumer 2 is being added, so partition 0 and 2 are still consumed by consumer 1, but 1 and 3 are being assigned to consumer 2. Okay. So this is the rebalancing algorithm that is also taken care at the consumer group end only. So I don't want to go into the details of it because it's a overall separate topic. So rebalancing protocol is itself a big topic, wherein like there is one leader elected in the consumer group. So one consumer will be the leader, and its responsibility is to prepare the plan that which consumer will be listening from which partitions. So as soon as rebalancing occurred, so rebalancing also has two strategies. Basically, one is eager rebalancing, another is cooperative rebalancing. In eager one, like it's a stop the world. So as soon as, first of all, now your consumer one is listening to partition 0, 1, 2, and 3. As soon as your consumer 2 joins, so it will stop everything, it will stop delivering messages to consumer 1, and now after reassignment only it starts delivering messages from partition 0 and 2 to consumer 1, and 1 and 3 to consumer 2. So as soon as consumer 2 gets joined in this consumer group, it starts like, it stops giving messages to this consumer 1, and after rebalancing only it starts again redelivering messages. Okay, now if we see some more consumers joined, now again rebalancing occurred, and partition 0 is now with consumer 1, partition 1 is with 2, 2 is with 3, and 3 is with 4. So this is how the rebalancing is. After rebalancing, this is how the structure will be. So if you notice that every partition is only consumed by one consumer, so it won't be the case wherein you have multiple consumers consuming from the same partition. So this is the basically rule wherein you have only from one single consumer group, you have one partition can only be consumed by one consumer, not more than one. Okay, but if you want like one partition to be consumed by multiple consumers, so that you can do by creating another consumer group. So let's see one more thing here. For example, you now keep on adding more consumers to it till the time your number of consumers are equal to the number of partition. Then that will be like each partition is being assigned to each consumer. But as soon as you keep on adding more consumers to it, the new consumer will sit idle. So it will not be delivered any of the messages from, or it will not be assigned to any of the partitions. But yeah, it's better to keep an idle consumer. So in case any of the consumer dies, for example, so that consumer can be utilized and by Kafka to, because again the rebalancing will happen and Kafka will assign some messages to this consumer 5, because if any of the consumer 1, 2, 3, or 4 gets died, so consumer 5 can be utilized in that case. Okay, now this is another thing that I was telling you, that for example, you want to consume data from a single partition. Multiple consumers want to consume data from a single partition. That you can achieve by creating one more consumer group. So here, first of all, there was one consumer group wherein there are 4 consumers and they are consuming from each partition. Right now, we have created another consumer group. Now this consumer group also, the consumers in the consumer groups are now consuming from partition 1 and 2. Consumer 1 is consuming from 0 and 1, and consumer 2 is consuming from 2 and 3. So this partition is now consumed by consumer 1 of this consumer group 1 and consumer 1 of this consumer group 2. So that's how you need to create another. And if you talk about these consumer groups, so every consumer is a separate process. You can see it, I mean, they might be running on a single machine, or you can also run them on a different machine. I mean, they are different processes altogether. Okay, so every consumer is kind of a different process wherein, or you can say different threads in a process. So yeah. Now we'll see how the commits and offset. So if any questions till now? So I'll assume it as a no. So I'll move ahead. So now we'll talk about commits and offsets. So whenever some consumer is listening from some partition, okay, so there are multiple, for example, this is the partition from which the consumer is listening to. Okay, now as soon as assume the case whenever the consumer connected first time and it is starting from the beginning of the partition, so it starts with offset 0. So and it's getting like from in first call, for example, there is a configuration wherein you keep like give me every 3 messages every time. So it is taking like 0 1 2 in the first call, another call it is taking 3 4 5, then in the next call it is taking 6 7 8, another call it is taking 9 10 11. Now if that consumer died and again it spawns up and it asks Kafka to give me the messages from the same partition, then Kafka will give it from the same offset, because Kafka doesn't know that this consumer has already listened to these many messages. So it is the responsibility of the consumer to just call a commit after like reading the messages. So it needs to commit the last committed, I mean, it needs to commit the last offset which it has already read or processed. Okay. For example, now in every call you are getting some messages and you have already called like the call for commit will be at offset 2. Okay, now rebalancing happens, for example some new consumer joins or something, and this partition is being assigned to some other consumer in the consumer group. So it will start getting messages from offset 2 only, because this is the last offset that Kafka knows that okay, this consumer has already read, this partition has already being read by this consumer group till offset 2. So now I should start giving it from offset 3. Even if you have processed these many messages, I mean, these many messages have been processed by the earlier consumer, but it didn't like commit the offset to Kafka. So these many messages will be processed by the consumer again. So these many will be the duplicate messages. So it is your responsibility, I mean, to make the consumer as the idempotent, so that if another like same message comes again, so you can handle it at like, if you are storing it in some database, you have some ID, and with that ID you can identify that this message has already been processed and now I need not do anything, it's a duplicate. Okay, so your consumer should be idempotent in this case. Now there is
Okay,
a concept, yeah.
yeah. So, what happens in the case, let's say, a new consumer group is added altogether, and that is requesting for a message? Will that message be delivered from the same offset the last consumer read that partition from, or it will start from zero offset?
I think in case of new consumer group, we will start from new offset. But yeah, there is also a configuration that you can seek. Like there is a seek API in consumer wherein you can give like specify that from which offset you want to read. Like this is also possible, but that is again you need to do it manually. If you go by Kafka automatic thing, so you that it will give you the messages from beginning itself. Yeah, otherwise you need to do it manually, like you need to specify the partition name and the topic name and the offset from which you want to
Okay.
read. Yeah.
Hmm. Okay. Thank you.
Okay, so now we have like concept of idempotent producer as well. So for example, earlier we discussed about idempotent consumers. Now it's a idempotent producer. Basically, if you are producing a message to Kafka and you are getting some acts from Kafka saying that okay, this message has been published to Kafka, for example, due to some network error you don't get an act or you don't receive an act, um, so you will retry that. Okay, so it's the Kafka should not treat it as a new message. So for that, you need to do some configuration to make your producer as an idempotent. So it will start keeping some local IDs on at their end, like so that it will come to know that it is the same request that is being coming to me again. So it will not do anything. It will just take it as a duplicate message and give the ACK. Now we'll see the message compression basically. So message compression is being done on the producer end itself. It's like a performance improvement basically. So like, for example, you are sending multiple messages from producer to Kafka broker. So it's a configuration, like you can batch some, you can specify like I want to publish a batch of 50 messages, for example. So you have a threshold of 50, and then whenever your 50 messages are being accumulated in the buffer, then only it will make a send call to Kafka. So this is just a performance optimization to just reduce the network calls that you are making. Now we have something called segments, basically in partitions. Like I told you, right? This partition is nothing but a log file. You can think it as a log file. So even if we are generating the log files for our services, like consider the example of log4j. So you have kind of logging appenders right over there, wherein you have like date or time constraints, like after every day you have a new file. Or you can have also a size constraint, wherein you can specify that after this file reaches this much size, then only create a new file. So similar way, you have a concept of segments here also. So every file is broken into segments. So every segment will contain the messages. For example, this file is you will consider this file as a complete file, which is broken into multiple segments. Every segment is containing some messages. So this segment is containing messages from 0 to 100. This segment is containing messages from 101 to 200. And there will be an active segment, which is currently the writes are being coming to this particular segment. So if anybody wants to write to that particular partition, so there is one active sub segment will be there, which is taking the writes and doing append only things at the end. Now we'll talk about the retention policy. So as you can see, like the smallest unit wherein you are actually writing the message is partition. So even if you have like so you have that partition on a single machine. So single machine has also some hardware constraints, like you have limited storage over there. So this is the retention policy that Kafka has. So by default it retains like messages for 7 days, but you can configure that in the configuration itself, that if you want to keep the messages for forever, or you want to keep the messages for some more like 30 days or something, so that you can configure, so that after that these messages will be deleted from Kafka. So I have a short demo planned. Let me see if I can. So the main component that like till now we have like Zookeeper, which is responsible for like coordinating or keeping the configuration of multiple brokers in Kafka. Okay, but in the new release they are like removing Zookeeper from this like jargon, and that I need to read that how they have done it. So maybe if somebody is interested, he can go into the details, but right now like we have like first of all we need to start the Zookeeper here. Okay, so this is I have installed like Kafka uh, binary on my machine, and I'm starting the Zookeeper here. So this you can see it will be running as a separate process on a separate machine. And this will also have a cluster altogether, like Zookeeper is also running as a cluster, so that you'll get the availability and all. And now I am starting the Kafka broker. Basically there's only single broker I'm starting on my local machine. So that also, if you have multiple brokers that are also running on separate machines, and every machine is responsible for a set of partitions. Okay, and every partition, like there will be a leader in the partition. For example, you have a topic called order topic, and you have multiple partitions in that. So partition 0 will also, there will be a replica of partition 0 also. So partition 0 will reside on two different machines. On one it will be acting as a leader, and on another it will be acting as a in-sync replica or follower. Okay, now I'm starting, like this is the producer. This is also like currently I'm using shell script basically to start a producer, but you have like Java libraries available wherein you can give the wherein your broker is deployed. So you can have the IP address of your broker and the port on which your broker is running, and you can start your, and also you need to define the topic name on which I've already created a topic called quick start events. Okay, so this producer is producing messages on quick start events topic, and it is the broker. So whenever there is a cluster, basically you can define any of the IP of the brokers basically. So for example, you have four different brokers, so you can give any IP of the four machines, any of the four machines. So it will automatically send, because every machine keeps the metadata about others. Okay, so this is the producer I have started, and this is the consumer I'm starting. So while defining consumer, also I'm specifying here from which topic it is listening to, and it is listening from the beginning. And yeah, it is also taking the broker URL basically. And there are some messages I've already sent to the before this meeting. So now if I send some message here, so it is getting delivered to this consumer. So it's a small just the introduction of Kafka, wherein you have set up Zookeeper, you have your broker in place, and you have one producer and one consumer. And before creating producer and consumer, you need to specify you need to create the topic first, and then on that topic you are creating a producer and a consumer. So yeah, that's pretty. Yeah.
Thank you for the demo. It was very informative. I wanted to ask, how do we recognize that, okay, we are facing this problem, so this is where Kafka can come in and fill in the gaps? How do you recognize that Kafka can be used in this particular use case?
So it's a asynchronous messaging. May I know who is?
Yeah, it was Akash.
Yeah, Akash. So it's basically asynchronous kind of messaging, wherein I told you earlier, right? Here we are doing synchronous processing, wherein you are calling the orders API and email service, right? In the synchronous basically. As soon as you get a call from create orders API, in that you are calling a REST API of, for example, payment service and email service. But if you want to make it asynchronous, or for example, here I have currently these two services only which are listening to these messages, right? Tomorrow there is another, for example, fulfillment service comes, which is responsible for fulfilling that particular order. Okay, then in this case you need to make changes in your orders API, right, to let it know that one more service it needs to be called, right? There is so it should know these all services. But in this architecture, it is not. It's overall a event driven architecture. It's overall a different kind of architecture, wherein you are processing the events asynchronously, not in the same in the same call you're doing. So therein this Kafka can fit in, or any other also. You have ActiveMQ, RabbitMQ, these kind of distributed messaging systems, right? But it's operating on a scale of trillions of messaging per day you can process with this Kafka cluster. So the scale is huge in this. Basically, that's why it is gaining popularity. I hope.
Yeah, yeah, that's good, Sunny. But Akash, in a way, what you can look at is any stream processing kind or any website activity related tracking that we do, metrics collection, otherwise monitoring. These are all places where logging aggregation, real-time analytics, basically wherever you need, you can use Kafka. There are many more ways, but this is where it's most probably being used, widely used across.
Yeah. I can give you one more use case wherein we had used Kafka in my previous company. So we had ample amount of deals. We have a deal service wherein we want deals to be indexed somehow, but we don't want to. So our main source of truth was MongoDB, wherein we were storing, or MySQL also earlier. So wherein we were storing the deals data. and we have like after a deal is created, we were just publishing the messages to Kafka cluster, and after consuming from Kafka cluster, we are indexing them to Elasticsearch. So this is how, I mean, now the indexing is totally powered by, or the searching is totally powered by Elasticsearch. So that's how, I mean, whenever you are doing the streaming of events and doing some indexing, or on top of that you want to create multiple views of data. For example, after reading one data, you want to create multiple views. In that case also you can use it.
Okay, that was
Yeah,
helpful. Thank you.
yeah. Basically, this is more useful in case of when there is high load, Akash. Like if you have only certain smaller set of data, it doesn't, like, this is an overhead if you were to use Kafka.
Okay.
Yeah, and there is one thing called change data capture. For example, like now the DBs like Couchbase and all, they are giving some like you can plug in the Kafka connector. So as soon as you are creating some data, doing some updates, like any DML you are firing, like create, update, delete or something, so everything will be now published to your Kafka topic. And now why using that, I mean, even if your DB got crashed or sometimes, you can again create the DB state. Why using that? Or if you want to take some action on your create, update or delete events, you can do it after consuming the events from there itself. You need not inquire from the DB again. So your load from DB will be reduced. You can directly like consume the events, consume the all the update, create and delete events from Kafka only, and do some processing over there. Yeah, this is also, you can read about change data capture, Akash. That is also a one good use case. Yeah.
Thank you, Sunny.
Yeah, any other questions?
So, Sunny, what was the use of Zookeeper that you were using while the demo? Like, I could
So
not
it is,
understand how. Yeah.
yeah, it is used to just maintain the cluster information basically. Uh, so you have multiple brokers, right? So everybody, whenever it is up, so it needs to know that, okay, where the Zookeeper is deployed. So broker should know about the Zookeeper node, and it will register itself as soon as it gets. So it manages the cluster information, and all the configurations of that particular broker are being managed by the Zookeeper only. But right now, as I already told you, that in the new release they are deprecating Zookeeper. So yeah, I need to read about that, how they are now solving the like.
Normally, yeah, zookeepers are used as orchestrators. Like
Yeah,
Sunny was mentioning the consumer threads and all, right? So it's like somebody sitting at the top saying, okay, 10 consumer threads are actually there. If one of it dies somehow, then zookeeper spawns another thread. So that's why it has all the configuration and all.
yeah, that's another yeah, use case.
So basically, it's an additional external sort of a service which manages the interaction. So what if, let's say, like Kafka is not dependent on Zookeeper, right? Let's say Zookeeper instance somehow dies or something, then overall Kafka performance would be degraded, right?
No, it will not perform only. I mean, if your Zookeeper is down, so it will not
Okay.
perform. Yeah, it's totally, I mean, that's why you set up Zookeeper also as a cluster. So Zookeeper also will be deployed on multiple nodes. So this should also
Okay.
be highly available. Yeah, system. Zookeeper is itself a, I mean, separate process which will be running on multiple machines. Yeah.
Okay, and now they are they're planning to make Kafka like independent of Zookeeper, is it?
Yeah, I've read it. Yeah, I've read it, but yeah, I
Okay.
didn't read the details of it. Yeah.
Yeah, got it. Thank you.
Yeah, if there are no more questions, so thank you very much, guys, for your patience and listening to me for 40 minutes. Yeah. Thank you so much.
Thank you, sir.